Okay, for unit 7, we're going to start with similarity. We're going to first let me define what similarity, what's congruency. We talked about congruency before. We used the symbol. Remember for congruent, before it was like an equal sign and a wiggly thing on top. Now for similar, it's just going to be the wiggly thing on top. Okay, so there's something that is going to be about the same on both. Now similar. Now something similar means is same shape. That wiggly thing on top means same shape. So we're not going to distort it. So obviously congruent, when I talk about before, part of it was same shape. Now, what does this thing mean? That the shapes are going to be the same. Okay, when we compare it, it's like, oh yeah, it's the same thing. They look exactly alike. Now, similar can be different size. Can be different size. Congruent was same size. Okay, what does that mean? Talk about the movies. Let's talk about, think of a movie theater. When you guys go to the movie theater, you guys look on the screen. There's someone that looks there's people there, right? Pretty big people compared to humans in the movie theater. What you see on the screen is basically someone, the image enlarged. But then when you see them on outside, they look the same, right? So same shape, they look pretty much the same thing. It's just that they're different sizes. Congruent, for things to be congruent, they have to be the same shape and same size. Okay, a little more definition. Maybe like Mr. Leonzo, a little more definition of that. Okay. Similar, we're gonna say, how do we know it's the same shape? Well, corresponding angles are equal. We're gonna write that thing down. So corresponding angles are equal. That's what same shape means. Okay, so that should be for congruent as well. Corresponding angles are equal. So if I'm looking at a picture and I look at the angle created by the two eyes and the nose of a person on the screen, and I was to measure it in person, it should be the same thing. Okay, we're not going to be like that. We're going to be looking at pictures or images that geometrical images, so like triangles, rectangles, or other figures. So those I'm going to say that corresponding angles have to be equal. Now, for similarity, corresponding sides are proportional. I'll talk about proportional in a minute. Corresponding sides are proportional. Might be like, what does that actually mean? What does proportional mean? So let me extend this. Hmm, We're gonna say corresponding sides. Corresponding sides make equivalent fractions. Make equivalent fractions. Okay, what's equivalent fractions? Something like 6 over 8, it's equal to 3 over 4, right? If we look at this as fractions, they can be simplified, and they simplify to the same thing. What's another way we can check? Because what if I'm not really good at simplified? What's another way I check for equivalency? 6 times 4 equals 24. 8 times 3 equals the same thing. So equivalency, equivalent fractions is if I simplify them, they simplify to the same thing. If I cross multiplied, they give me the same result. That's what equivalent fractions or corresponding sides are proportional. That's what I mean. Now for congruency, we talked about this before. Corresponding sides are equal. Corresponding sides are equal. That's why we talk about congruency first, because it was pretty simple. Everything is equal. Same shape, same size, the angles, the sides, everything is equal. That's what we talk about that before. Remember last semester we talked about congruent triangles. Now similar is the same shape, so the corresponding angles are equal, but they can be different sizes. And we're for us to check that, sides have to be proportional. Okay, we're going to take a look at questions 1 and 2. And then for today, so that's going to help us out. But before we move on, let me talk about a formula we're not quite going to use today, the distance formula. We're not quite going to use today, but I need you to know it. This formula, the distance formula, it is going to be used a lot. Okay? It is a very, very important. It is the formula to find that distance between 2 points. So I have here the coordinate plane, and we're going to say, okay, if my points were horizontal, so they were like this, I can easily count the distance between them, right? I just count the squares. In this case, there's 3 squares between them. If I'm counting by ones, if each of my squares is 1, well, the distance is 3. If I was counting by twos, the distance is 6, right? I need to know by how much am I counting each square. And for that, obviously, we use the X and Y axis and all the stuff. So if my segment, oh, I'm going to use this up here instead. If my 2 points were horizontal or they were vertical, yeah, it's easy. Just count the squares. Make sure you know if you're counting by ones, by twos, by how much, and that will give you the distance. That's not a big deal. But what if my points are not on the same line? Let's go like this. What if my points are like that? And I need to find the distance between them. I cannot just count squares. So matter of fact, what we're gonna do, my first point, I'm gonna find the coordinates of this one. In this case, I don't have my axis, right? I don't have an x-axis, I don't have a y-axis, but I'm just gonna call this the x of my first point and the y of my first point. So I'm gonna call it x1, y1. My second point, I'm going to call it x2, y2. So basically the x of the second point, the y of the second point. Those are the terms I'm going to use. Interesting though, connecting this horizontal and vertical line, I'm going to come up with another point. I know these 2 points have the same x value, right? If I know the coordinate plane, remember when you do an x and a y uh, axis, remember when you do those, if you notice, they have the same x coordinate. So I'm going to say the values of here, the x2. Now on the height, if I was to compare it on my on my axis, they have the value is y1 because they have the same height as the first point. Okay, and I'm interested in the distance right here, the hypotenuse of this triangle. Let me call it C for right now. I'm interested in that value. Hmm. Interesting though. Let me take a look at this side right here. Let me highlight this side. I know right now I can count the squares, right? There's what? 1, 2, 3, 4, 5, 6 squares. I don't know if I'm counting by ones or by twos though. If I was counting by ones, my distance is 6. If I was counting by twos, my distance is 12. But interesting is that the x values, the same thing, right? So my x value doesn't change. The only variance is y2 minus y1. If I knew my coordinates, the y of the second point minus the y of the first point, that gives me that distance. And I'm going to say here at the bottom, if you notice, the y's are the same thing. So that's not really going to change much. What varies, what changes is x2 minus x1. Again, I can count the squares, but I don't know if I'm counting by ones or by twos. Some of you might be like, what do you mean with counting by ones or by twos? Okay. Sometimes we have questions where they say this is one, this is two, this is three. They're counting by ones. Sometimes we have questions that say this is two, this is four, this is six. That means they're counting by twos. In our case, we don't know because we don't have the axis. Okay, so what are we gonna do? I remembered back in the days we used to have a right triangle, but that's what we have here. And now you remember I used to call this side C, this is A, this is B, and people used to call it C squared is equal to A squared plus B squared. Remember that? So that's, let me write that down here. I'm gonna write C squared is equal to this whole thing, x2 minus x1 all squared plus this whole thing right here, y2 minus y1 all squared. I remember that from c squared equals a squared plus b squared. But if you notice, I'm not solving for c squared. I'm solving for c. So the way I'm going to undo a squared, I'm going to do a square root. So I'm going to come out with, let me write this in black because this is a formula we're going to use a lot. Here I have that c, which is my distance formula, is a big square root. Inside I have x2 minus x1 all squared. So basically, what's the difference between the x's plus y2 minus y1 all squared? What's the difference between the y's? This, ladies and gentlemen, this right here is the formula to find the distance between two values. We're going to call this the distance formula. Okay. Again, if there's one thing, if there's only one thing you guys are going to learn today, please make it this formula. Very, very important. We're going to use this formula even after Unit 7. It's a very, very important formula. Let's learn how to use it. Let me write it over here again. It's x2 minus x1 all squared plus y2 minus y1 all squared. And this is inside the square root. Okay. So what do I mean with that? Find the distance between each pair of points. So I'm gonna go -4 minus 1 all squared. Notice how I did the second x minus the first x plus I'm gonna write 8 minus a -4 all squared. Notice how I did the second y minus the first y. I know I have minus negative, and all this is inside a square root. And then inside of here, I have -4. I know -4 minus 1 is -5, right? So I have -5 all squared plus, I know this is become two negative signs become a plus sign. So plus 12 all squared inside a square root. I know I mentioned about a calculator I give you guys. So let me go here. Oops, not pi. I'm gonna do a square root because I have a square root. And then I have a parentheses. I have a -5 close parentheses squared plus 12 squared equals 13. Now, you guys might be thinking, Mr. Leonzo, really the parentheses are gonna kill me? Well, let me show you something really quick. What if I do square root and I do 5 squared plus 12 squared? I get the same thing. Now, interesting, you don't really want to be typing the parentheses squared. Don't do it. Just ignore the signs as well. Notice how on our question was -5. And at the bottom I wrote 5, positive 5. Well, since you're gonna square it, right? Negative times a negative is the same thing as positive times a positive. Since you're gonna square the value, then who cares if you write it as positive? Ignore the negative sign. Don't ignore this plus sign though. And then notice I went 12 squared. Okay, so having that said is 13. Let me come back to my notes here. This is 13. The distance between those 2 points is 13. Okay, let me remember the formula. Remember I gave you guys the formula? The second x minus the first x all squared plus the second y minus the first y all squared inside the square root. So I'm going to write that thing here. I'm going to go -1 minus 7 all squared plus 4 minus 8 all squared inside the square root. What's -1 minus 7? Well, that's -8, right? So I have -8 squared. What's 4 minus 8? Well, that's a -4. I'm using parentheses because of the negative signs. Now, when I'm going to type it on my calculator, I'm going to go 8 squared plus 4 squared. And it gives me 8.944. When we don't tell you how much to round it by, we usually round it to two decimal places. My third is too small, so 8.94. What I want you to see is when I deal with distance, sometimes my answer might be a whole number. Sometimes my answer will be a decimal. It is okay. Make sure you learn the formula. Like I said, we're going to use it, not today, but we will use it many days for Unit 7 and even after Unit 7. Okay, so for today, it was just about similar and congruent. Let's take a look. I'm only going to look at questions 1 and 2 for today. Determine whether the line segments are similar and or congruent. So they look like the same shape, right? They're line segments. Remember so I have the same shape. Well, it could either be similar, it could be congruent. They look like line segments. Now, what about the size? Well, I could come up with those 2 points and I can say, well, I'm gonna come out with these. This right here, I can count the squares is 4 squares and 2 squares here. So this right here is the square root of 4 squared plus 2 squared, which is about 4.47. I found the length of my segment. On this other triangle here, this is 2 squares. This one is 4 squares. So this one is the square root of 4 squared plus 2 squared, which is about 4.47. Okay, I guess they have the same size as well. So that's congruent, right? Remember how for similar, I said it has to be the same shape and can be different size. Can be. I didn't say it has to be. I said it can be different size. Remember, if you look on the front, what's the definition of similar? Same shape and can be different size. Well, it is congruent and it is similar. Now let's take a look at this other one. I'm gonna say they have the same shape. I'm comparing two line segments. They have the same shape. When I look at one of them to find the distance between them, I see this is 5 squares and this is 3 squares. So I have to do 5 squared plus 3 squared, the square root of that. The length of this segment is about 5.83. Okay, so the size is 5.83. When I look at my other triangle, or my other line segment, I mean, and I create this is 1 squared, this is 11 squares. So I do 11 squared plus 1 squared, the square root of that. I type it on my calculator, it tells me about 11.05. Um, these are different sizes. Okay. I was comparing, they look like line segments, so same shape. They're just different sizes, right? One of them is 5.83, the other one's 11.05. So definitely not congruent. So it's not congruent and it's not congruent. It is similar though. I'm gonna choose this right here. It is similar because they have the same shape, can be different sizes. They're similar, just not congruent.